So welcome everyone and welcome to this lecture. This is lecture number 4 and we are doing revision of the entire course by solving a paper of the previous previous attempt 2023, and we'll continue with this. So today's class we will solve the paper from 31st of January, shift 1, and we'll see what type of questions you can expect in the exam. So this is the first one, and as you will see, most of the questions are pretty straightforward. This is the first one coming on your screen right away. Answer can be given straight away. The ratio of Cp to Cv varies with temperature as. For an ideal gas, the ratio of Cp by Cv, and the correct answer is
1 sir, T power 0.
yes, T to the power 0. Remember, Cp by Cv. Cp by Cv is nothing but gamma. This is nothing but 1 plus 2 by F. Do we remember this?
Yes sir.
Where F is the degrees of freedom. You can see the question is straightforward. Nothing should confuse you if you just remember the definition of things. Solving the paper will also give you an idea of what type of questions are coming, bound to come, supposed to come, and if you have to revise something, anything, how and what to revise. This is a straightforward question. N, A, Q and I are given as below. Read the questions carefully because they might just change something. Some small thing they might change. What is the expression for the drift velocity? And the answer is
Option 3 sir.
option 3, sir. That is the problem with us, that we don't remember simple things and simple formulae. I is NaeVd. N is the number of electrons per unit volume, number density. A is the area of cross section. E is the charge of electron. Vd is the drift velocity. The drift velocity becomes I divided by N A into E. The answer is I divided by N A Q. If you don't remember simple things, well, you might pay the costs for that. This is the next one. R, XL and XC denote resistance, inductance, inductive reactance and capacitive reactance. Which of the following would be a dimensionless quantity?
Option 2 sir.
Option 2. You should take some time to read the question, understand. Do not mark your answers in a haste. If you mark your answers in a haste, you might make a mistake. Remember, the dimension of R is same as the dimension of XL. Ohm is same as the dimension of XC, is same as the dimension of Z. All are. In fact, resistance, inductive reactance, capacitive reactance, collectively you can call them impedance. So if you call something as impedance, If it is a resistor, pure resistor, it becomes its resistance. If it is a pure inductor, it becomes inductive reactance. If it is a pure capacitor, it becomes capacitive reactance. If it is a combination, well, you already know the name. The name is impedance. So impedance is the word that you must remember. The units are same. This is the next one. A force 200 Newton is exerted on a disk of mass 70 kg as shown. Find the normal reaction given by the ground. It's a very simple question. I'll give you a minute to solve it. This force is like this. You can resolve it into two components. One would be downwards and one would be like this. How much would be the downward component? It will be 200 sine 30. So this would be 100 newtons is the downward component. The weight is 70 newtons. So it is 700 in the downward direction. The normal reaction is going to be upwards. So the answer for normal reaction, because this is remaining in equilibrium in this vertical direction, the answer is 800 newtons. That is the answer that we are looking at. A simple question. And you should be able to get the answer. This one.
మొబైల్ కనెక్ట్ అయ్యి మొబైల్ మాట్లాడదు.
Shall we move ahead?
Yes, sir.
Okay. This is the next one. Which of the following graphs depict the variation of electric potential? Remember, so many graphs we have drawn with respect to the radial distance from the center of a conducting sphere. Which graph correctly represents the potential, the variation of electric potential from the center of a conducting disk?
Sir, option 2, sir.
Option 2, sir, is wrong, sir. Option 3, sir, is right, sir. Potential inside at any point inside the sphere is an equipotential surface. K, capital Q by R, is the potential inside or on the surface. If small r is less than or equal to capital R, V is equal to KQ by R. If R is greater than capital R, given you all types of graphs, you need to go back and have a look and refresh your memories. There is nothing that I can explain here because I already given you this graph. Anyways, move on to the next one. In a sample of hydrogen atom, one atom goes through a transition 3 to ground. Wavelength is lambda 1. Another atom goes through transition 2 to ground. What is the ratio of lambda 1 by lambda 2? I'll give you a minute to do this. 27 by 32. Remember the formula for 1 by lambda. We have done it. R Z square, where Z is the atomic number, into 1 by N1 square minus 1 by N2 square. Yes or no?
Yes, sir.
In first case, in case of lambda 1, the wavelength is lambda 1. We don't know R. Well, we know R, but we don't have to put the value. Z is 1. Even if Z was something else, ratio mein it is going to get cancelled, so I'll just write it as RZ square. N1 is 1 and N2 is 3. So it is 1 minus 1 by 9. 1 by lambda 2 will be equal to again RZ square. N1 is 1. N2 is now 4. You just have to find out the ratio. In the first case, I think it is going to come as 8 by 9. In the second case, it is going to come as 3 by 4. When you find out lambda 1 by lambda 2, I think you are going to get, and don't make a mistake in dividing, because if you make a distance dividing, mistake in dividing, you might get 32 by 27. The answer is 27 by 32. You must remember that we had done a lot of questions based on this ratios and different things. If you still have a doubt, you can go back and have a look at that lecture, and you will find lots of questions based on this. Here, next one, it is as simple as it may get. And if you can see, this same question appeared in one of the previous sections which we had discussed in one of the previous classes. Simple question, what is the total number of oscillation of blocks per unit time? So basically they're asking you what? They're asking you frequency. Option 4 is correct. How are these two springs connected? Are they connected in parallel or are they connected in series?
They are connected in parallel, sir.
They are connected in parallel, so the effective spring constant becomes K plus K, 2K. When you know that the effective spring constant becomes 2K, you can straight away remember the formula of frequency. Frequency is 1 by 2F under root of K effective by M. So it is 2K by M. That is your frequency. Straight away, you just need to apply the formula. Remember, don't make a mistake of dividing it by 2 pi or multiplying it by pi. You might always make a mistake. Even I make a mistake sometimes. Remember, time period is 2 pi by omega. Frequency is 1 by time period. So in time period, 2 pi will come in the numerator, and frequency 2 pi will come in the denominator. Remember this, don't make a mistake. The only mistake you can do is just write the opposite answer, and that won't be good. Take the ratios correctly. This is the next one again. As I told you many times that there are some questions which are just based on your knowledge. This is the one that comes in that category. Consider two statements. One is an assertion, the second one is a reason, and I wait for your answers for this one. So what's the answer here? Remember this Davison-Gummer experiment, it verified the wave nature of electrons. This experiment verified the wave nature of electrons, and a beam of electrons actually shows wave nature, and that was confirmed by this Davison-Gummer experiment. Therefore, the correct option is option 1. So remember this. Note this down. There are some questions which are based on your information, and this is the information that you must remember. As I told you, when we talk about wave nature, remember that de Broglie wavelength? Remember that? Small particles, if they are moving very fast, they have a wave nature. Remember that?
Yes, sir.
That was, and this Davison-Gummer experiment verified that wave nature. Shall we move ahead? This is the next question. A projectile is launched. Initial velocity is u. Maximum height root 3 u by 2. What is the time of flight? We have done a lot of questions on this. This should be an easy one. Option 3 u by g. Why did it take you 10 minutes to solve this question? What was so difficult here?
Some clumsiness, like with the horizontal velocity at maximum height. I was thinking that at the topmost position it has zero velocity, and I'm thinking in that way, but at last I came to know that it is a horizontal velocity.
Thank God that we came to know now, 5 days before the exam, that we know that at the highest point, the velocity is not zero. If I remember correctly, 3 days before I also told you the same thing. At the highest point, velocity is not zero. 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 Then what is zero at the highest point? Nothing is zero at the highest point. What is zero at the highest point?
Sir, come again.
What is zero at the highest point?
Vertical velocity.
Thank God. Vertical velocity. Vertical velocity is zero at the highest point. Thank God. And the horizontal component of velocity is always remaining same for a projectile, and the horizontal component of velocity, what I am writing here, I have also gone mad. Horizontal component of velocity ux, which is nothing but u cos theta, is root 3 by 2u. So from here, theta is 30 degrees. Time of flight is 2u sine theta by g. I hope all of you remember this one at least. If you are taking so much of time to solve questions like this, whew, nothing should be said after this. Anyways, I hope that you are able to recollect the same question 5 days from now when you are going to sit for your exam. Same question may come. Then remember, at the highest point, velocity is not zero. 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 This is the next question then. A diatomic gas is taken from point A to point B in a thermodynamic process as described in the pressure volume graph. The change in the internal energy is how much? How I am supposed to find out the change in internal energy for this process? Yes, tell me. How did you get the answer?
Sir, I have taken the process as adiabatic.
Deep breaths. Deep breaths. Close your eyes. Meditate. Then open them slowly. And tell me, from where did you find out?
Sir, option B. Option B.
How did you get that answer? That is the question. I'm not worried about the answer. Where did you get that process is adiabatic? Do you remember how does the PV graph of an adiabatic process look like? Does it look like anything close to that?
I have taken formulas at du equals to ncv dt.
Okay, you have taken the formula as du is ncv dt. Now what next? Do you know the value of cv?
Yes, sir.
How
3r,
much?
3r by 2.
3r by 2. Can you tell me how did you find out that cv is
5r by 2.
Hang on. What exists? 5 by 2r into n into delta t. 5 by 2r into n into delta t.
We can write delta t as 2 by r minus 4
You can write nr delta t as 5 by 2 p2 v2 minus p1 p1. After that, you have to multiply and divide and subtract When you multiply and divide and subtract correctly, you end up with option 1. I don't know how did you get option 2. Anyways, that is the correct answer that we were looking at. Yes, my dear friend.
Sir, it is not constant volume. So why you have taken CV?
Deep breaths. Deep breaths. Close your eyes. Again, think about what are you asking me, and then ask the question again. Yes, think and ask. Yes, ask now. Ask. Ask the question again. What is the question?
Sir, we use this formula for isochoric process, no sir?
Okay. Which formula?
Delta equals to NCV delta T.
What is delta U? What is delta U?
Change in internal energy.
Change in internal energy. What type of function is okay? NCV delta T. So this is the formula for isochoric process. Okay. What is the change in internal energy for isobaric process?
NCP delta T.
Very good. What is the change in internal energy for isothermal process then?
0.
Well done. So delta U depends on the process, right? If we do it by different process, we will have different change in internal energy, correct?
Yes, sir.
Okay, well done. New information has come into light. New research has come into light. Let us go back to the old research that we have done. Because once we discover something new in physics, we must reason it. Why this is new? So let us now go back and see what is the old research. It takes time for me to go back in time. Time travel is not possible, but I have this special ability of going back in time and finding out certain things. This is the reason that we are doing all these revisions, so that we can go back in time and see. The past is always good. The future is always uncertain. So we look at the good things in the past. Come on, come on, come on. Where is this? Where is this? This is this. This is this. This is this. Here comes a blast from the past. Maxwell's law of equipartition of energy. U is N by 2 FRT. Internal energy of a gas. Internal energy of a gas. F by 2 nRT. Internal energy of a gas. Specific heat at constant pressure. Constant volume. Amount of heat given during an isochoric process is NCV delta T. Amount of heat which is given for an isobaric process is NCP delta T. Dun, dun, dun. Cp is F by 2 plus 1 R. Cv is F by 2 R. Ooh, now comes the most important aspect. State variables. Define the state of the gas. State variables does not depend on path. Oh, new research. For any thermodynamic process, internal energy The change in internal energy remains same, my dear friend. It is N, CV, delta T. State variables. Delta U does not depend on path or process. Past is always good. Future is always uncertain. And if you remember, if you forget simple things from the past, this was a question from the past, which you all did it with your own hands. Go back in the past, have a look at the glorious past that you had, and try and remember simple things in the present. Once you remember simple things from the past in the present, you end up with the correct option. Change in internal energy is a state variable. Internal energy is a state variable. 5 days from now, and I hope that you can recollect it in the examination hall, because if you again forget, you can always go back in the past in your dreams and recollect what we had discussed. This is the next question. A conductor of length L, area cross section A, drift velocity Vd, when used across a potential difference of V. Another conductor of same material and length L, but double the cross section area is of first. What would be the value of drift velocity if I recollect? Same question probably I did in the class. Not even the wordings were different. Anyways, let's see if you can get the answer for this one. So now let me do it in this way. NAEVD. This is I, my dear friend. I is not the same. I is not the same. Potential difference is same. Potential difference. V is equal to IR. So I is V by R. Let me put I as V by R. V by R is equal to NAEVD. R is the resistance. Rho L by A is equal to NAEVD. Now you see, my dear friend, ding. VD is directly proportional to V and inversely proportional to L. That does not change. In my question, blast from the past, was specifically mentioned only diameter is changed. See? Exact copy. Exact replica. The only difference is my question had diameter, here they have area. Blast from the past, from the class, from the past. Remember simple things in life and do not rush on to answers very quickly. I hope I have made my point. Yes or no?
Yes, sir.
So you also remember, if you have to revise, what you need to revise. This is the next question. A swimmer swims perpendicular to river flow. Done 1500 questions on this. What is the velocity of river flow? Ta 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 ta. Ta 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 ta. Let's see who gets me the answer for this one. So he is going to move here. This is the velocity of man with respect to river. This will be the velocity of river with respect to ground. His net velocity will become like this. You know this angle as theta. So you can find out the value of tan theta. Tan theta will be equal to 750 divided by 1 kilometer. So it will be equal to 3 by 4. Yes or no?
Yes, sir.
That will be equal to velocity of river, the horizontal component divided by the vertical component. So the velocity of river has to come as 3 kilometer per hour. Chalo. Let us move on to the next question. And the next question is this one. A bar magnet with magnetic moment of 5 ampere meter square is laying at stable equilibrium in an external magnetic field of 0.4 teslas. Work done in rotating the bar magnet to the position of unstable equilibrium is. Same question could be asked for a current carrying wire. The same question could be asked for electric dipole. The same question could be asked for a current carrying loop. The concept remains same. So the initial energy is minus m dot b, m into b. M is the magnetic moment. B into cos of 0. Final energy minus m b cos of 180 degrees. Work done in rotating delta u. If I find out the work done by the magnetic force, it will be ui minus uf. If I find out the work done by the external agent, it will be uf minus ui. It's not going to move on its own. It has to be moved by an external agent. So it will be minus mb cos 180, which is plus mb, minus mb cos 0. So it will be 2 times m into b. You just have to multiply 2 with m and b. I don't think multiplication of 2 by 5, which is 10, and 10 by 0.4, which is 4, should have taken so much of time. Anyways, 4 joules is the answer for this one. Chalo then, let's move ahead and move on to this question. When we were doing polarization, I hope we have covered this. If we have not covered this, this is the time that we cover this. The question is long, but the answer is very short. Unpolarized light, whose intensity is I naught, is then incident on a polarizer. So the intensity will become I naught by 2. Then it goes through polarizer B, which is inclined at an angle of 45 degrees. So it becomes cos square 45. Then this goes through polarizer C, which is again, it goes through C, which is inclined at an angle of 45 degrees. Then it goes through B, which is again inclined at an angle of 45 degrees, because A and B are perpendicular. A and B are perpendicular. Then I have in between one at an angle of 45. So angle between this and this is 45. Angle between this and this is 45. Should not take much of rocket science to do understand this. Cos 45 is 1 by root 2. Square is 1 by 2. 1 by 2 into 1 by 2 into 1 by 2. Nowhere I get 8. Nowhere I get 4. I only get 8. So that is the answer for this one. That takes us to the next one, and this is the next one in the same category, same paper, and you can see how questions from different sections come and the number of questions. If we increase the temperature of a semiconductor material, then the effect on the resistance and the number of electrons in the conduction band, what happens? And the answer is when you increase the temperature, the distance decreases, the number of electrons in the conduction band increases. I had given you that as a note. Please go back and check it. That will take us to the next question. Oops. That will take us to the next question, and this is the next question. Question from SHM. A particle performing SHM of amplitude A. The maximum potential energy of the particle is 25 joules. Find the kinetic energy at A by 2. Everyone is there in the class? Yes or no? This is the question. So it is given that the maximum potential energy is 25 joules. That means the total mechanical energy is 25 joules. So the total mechanical energy is 25 joules. Now, when the value of x is a by 2, you can find out the potential energy. Potential energy is half m omega squared into x squared, or half k into x squared, no matter how you write it. When I put the value of x as a by 2, it becomes half m omega square into a square by 4. The maximum potential energy is basically your half m omega square, which is nothing but half k, into the amplitude square, a square. So the potential energy maximum, which is the total mechanical energy, is 25 joules. Half m omega square a square is 25 joules. Right now the energy it is having is half m omega square a square by 4 in form of potential energy. The rest will be in the form of kinetic energy. Total energy is 25 joules. 1/4 of it is in the form of potential energy. 3/4 of it would be in the form of kinetic energy. So the answer for kinetic energy will be 3 by 4 times of 25. Remember, the total mechanical energy remains constant. Do we remember this? Do we remember this? I hope everyone is there. I am not able to hear your voice. So the answer in this case would be 2. 3 by 4 of 25 is 18.75, and that is the answer that we are looking at. Not able to hear your voice. Let me move on to the next question. And the next question is like this. Remember, see the pattern of questions, see the number of questions from where it is coming. One question definitely comes from gravitation, as you can see, and similar question has come in all the previous attempts. Different sessions, same question have come. At height h is equal to 3r from the earth's surface, the value of acceleration due to gravity is g1. At a depth d below, the acceleration due to gravity is g2. If G2 is 4 times G1, find the depth. The radius of the earth is 6400 kilometers. I'll give you 2 minutes to solve this. So the first thing is at a height h is equal to 3r. Remember the value of g is always given by gm by capital R square, where r is the distance from the center of earth. Now the value of g1, let me use a different color pen. The value of g1 will be equal to gm divided by, it is at a height of 3r, so it will be 4r whole square, so that will be gm by 16r square. That is the value of g1. Now g2 at any depth will be equal to g on the surface. This is g surface divided by 16. Let me write it that way so that g surface get cancelled. G surface into 1 minus d by r. This is g2, and this is nothing but 4 times of g1, so this is 4 gs by 16. 4 gs by 16 becomes gs by 4. Gs and gs get cancelled. 1 minus d by r is 1 by 4, so your d by r becomes 3 by 4. If your d by r becomes 3 by 4 and r is 6400, your depth will become 4800 kilometers. I hope everyone understands this. Yes or no? Do we understand this?
Yes, sir.
Okay. Let me move on to the next one. This is the next one. A neutron can break into a proton, but proton on its own will not break into a neutron because
Option 2.
the rest mass of the neutron is more than the rest mass of the proton. We all understand this?
Yes.
Okay. Let me now shift to the second category. In this, you will have to give the answer up till 2 places of decimal. I hope you know the drill. So there are a couple of questions here, and this is the next. This is the one. Remember, I gave you an entire table of this. The question is from the table. A solid sphere is rolling on a smooth surface with kinetic energy of this. Mass of the sphere is 1 kg. What is the speed of the center of mass in centimeter per second?
1 minute.
If we talk about the kinetic energy, it will consist of two parts. One will be the kinetic energy of translation, half mv square, yes or no? Then the other one will be the kinetic energy of rotation, half I omega square. I is 2 by 5. So I can write it as 2 by 5 into m into v square. That will be the total kinetic energy. I think when you add them, you will get the answer as 7 by 10 mv square. This 7 by 10 mv square, which is the total kinetic energy, pure rolling, that can be written as 7 by 1000 here into mv. So from mass is given as 1. From here you can get the value of velocity as 1 by 10 meter per second, but they have asked the answer in centimeter per second, so it becomes 10 centimeters per second. So the answer becomes 10.00. Do we understand this? You understand this? Do you understand this?
Yes, sir.
Okay, then this is the last question from an LCR circuit. In an LCR circuit with an AC source, current and voltage are in the same phase. What type of circuit this would be? It's an LCR circuit, but current and voltage are in the same phase. In which condition is the circuit? Current and voltage in the same phase. Which condition are we talking about?
Steady state, sir.
Steady state, sir. Okay. Steady state. What do you mean by steady state? Okay, this is something which is known as resonance. I hope this word you would have heard somewhere. This is known as resonance. The circuit is in resonance. Your XL becomes equal to XC. Your impedance becomes minimum, and the minimum impedance becomes R, because XL and XC are same. So you have to find out the current in the circuit. When they are asking about current, they are asking about the RMS current. The value of RMS current will be equal to Vrms. V is given as 220. RMS value would be given. Here the impedance Z will be equal to R. That will be equal to 20. So I think the answer that you are going to get will be 11 amps. So the answer will be 11.00 in this case. Anyways, this was this paper. I hope you can have seen what type of question has come, from which topics questions have come, and you have also seen what are the level of the questions that have come. That is the only reason that we are doing this exercise, where we are solving up the paper so that you get an idea of what you have to revise, how much you have to revise, and what all points you have to see while you are revising. Don't have to do a very detailed revision. You just have to go through the questions which are coming, and you just need to remember those points that we had discussed in the class. Make a short note of all these formulae. Once you are revising a topic, just make a quick note of all the formulas. That will help you in remembering them and in recollecting them in the examination. All 5 days down the line you will be having your exam, so I would suggest just go through this and just write them very quickly. It will hardly take, if I talk about 25 or 26 chapters, one chapter will hardly take 10 minutes to write, so you can just do it in a day. and then that you can keep that as your reference. Remember, the exam is very simple and very simple questions come. If you cannot solve a question in 2 minutes, just leave it and move on to the next one, because if you are not able to solve in 2 minutes, that means you're probably on the wrong track of solving it. Even the calculations part, as you can see, are very very simple. There are no complicated calculations anywhere involved. You don't even get answers in decimals. If the answer is in decimal, they will convert it into whole numbers. So don't worry about the calculation part as well. The things are very simple. Just remember simple things and don't forget them. On that note, I'll take your leave, and let's see if we meet tomorrow. Take care and God bless all of you. Bye bye.